Hello, I'm going to uh, expose some uh, some something about of the discrete sums of real numbers, numbers beyond the ordinary, the transcendental numbers. The numbers, as we know, later we can put them on a straight line, and the notion of numbering its position on a straight line seems at first glance straightforward. But while real numbers include both nice, predictable decimals and non-repeating irrationals, there exists a category even more elusive, numbers that cannot be expressed as the root of any algebraic equation with rational coefficient. And these numbers are called transcendental numbers. These enigmatic quantities, called transcendental numbers, occupy a mysterious realm. Unlike rational or algebraic irrational numbers, they defy capture by simple algebraic expressions. They are decimal expansions, wander endlessly without pattern or repetition, and they cannot be marked out by any straightforward construction using only arithmetic and roots. Among these numbers, the most famous are pi and e, the Neperius logarithm. Their presence permits geometry, calculus, and the fabric of mathematical thought surfacing whenever we attempt to measure cells or understand growth and change. For centuries, mathematicians passed over their nature, recognized their existence, but unable to pin down their precise value or location on the number line. The most famous is, of course, number pi, which is known as the Archimedes number. In the antiquity, the value of pi was estimated to lie between 1.2 and 1.6 based on measurements only. The first calculations of pi was performed by the Greek mathematician and engineer Archimedes, who demonstrated that pi falls between 3 plus 1 over 7 and 3 plus 10 over 71, or equivalently between 22 over 7 and 223 over 71. While the latter approximation is closer to the true value of pi, the former became more widely used due to its simplicity. 22 over 7 approximates it as 3.14, which is why Pi Day is celebrated in schools on March 14th, and some also observe it on July 22. How to calculate transcendental numbers? It is not possible to determine the exact value of a transcendental number. We can only approximate it. If x is such a number, it must be lie within a certain interval between two integers, say n and n plus 1. Since the interval is between two consecutive integers, its boundaries cannot be integers themselves, but rather two successive fractions, let's say p over q and p plus 1 over q. We have pq, we have x between p over q and p plus 1 over q. And the length of this interval is 1 over q. The number x is closer to either p over q or p plus 1 over q, with the absolute approximation error defined as delta equals x minus p over q. The maximum possible error is 1 over 2q, occurring when x lies exactly midway between these two fractions. The quality factor lambda of an approximation represents the ratio by which the actual error is smaller than the maximum possible error. This can be expressed as absolute x minus p over q less than 1 over 2 times q, or equivalently that lambda greater than 2 plus q absolute value x minus p over q. Clearly, a larger value of lambda indicates a better approximation. Archimedes determined that pi lies between 3 and 2 over 71 and 3 plus 1 over 7. His selection was not accidental, but the method behind this choice remains a point of interest. Several centuries later, around 1600 AD, a Dutch scientist discovered a more accurate approximation of pi using the fraction 366 over 113. Thank you very much.